Okay, we're going to look at graphing a line by calculating the x and y intercepts. So the x-intercept is going to be where your line crosses the x-axis. So just a little sketch here. So any point along the x-axis could be an x-intercept. And of course, the y-intercept is where your line could cross or will cross the y-axis. So if you're given the x and y intercepts, you can just plot those 2 points, then you can connect it, and there's your line. Sometimes you're going to need to calculate it though. So usually you want to use this method when your line is in standard form. So we're looking here at this first line here, 3x take away 5y plus 15 equals 0. That's in standard form because the x and the y variable and the constant value are all on the left side. So when you're in this position, you can calculate the x-intercept if you let y equal 0. So I'm going to go like this, x-intercept, and I'm going to let y equal 0. So I'm going to go here, and I'm going to substitute 0 for y, and then I'm going to solve for x. So again, this multiply is going to give me 0. And then I just got an equation I got to balance, so balancing the 15. And of course, isolating the x. Now what I've just created there is the point -5, and remember we let y equal 0. We can let x and y be whatever we want, but when we want to zero in on the intercepts, we always let the other one equal 0. For instance, now I'm going to calculate the y-intercept, and I'm going to let x equal 0. So I'm going to go back here to the beginning, and I'm going to substitute 0 for x. And then do the same thing, I'm going to balance for y. So again, balancing, making sure we do the opposite operations, isolating the y. So we get y is 3. Now that's the point 0, 3, because we let x equal 0. So now there's my 2 points, -5, 0, and 0, 3. So I'm going to plot -5, 0, 1, 2, 3, 4, 5. It's going to be right there. And 0, 3, 1, 2, 3. And there you go. Now I can connect those two. And there's my line. Now I got another example up here. This one's sort of, and kind of like to call it half standard form because they do have the constant already on the right side. So same idea. I'm going to do the x-intercepts. I'm going to let y equal 0. So I'm going to go here, and I'm going to substitute 0 for y. And we're going to balance. So x comes out to be 6, so that's the point 6, 0. And then I'm going to do the y-intercept. So I'm going to let x equal 0. So I'm going to go back here. Now you could, sorry about that. Now you could actually calculate the x and y intercepts when the line is in mx plus b form. But that's going to be a little bit more work than actually you need to. I apologize for that. That should be 3y. Because then you could just use the slope intercept method or table of values, but you still could do it. So again, you just calculated the point 0.04. So again, going back here, I'm just going to change the color. 6, 0, 1, 2, 3, 4, 5, 6. It's going to be right there. 0.4 will be there. And then I can connect these 2 points. Don't really like the way that line came out there, so I'm just going to straighten it out a bit. There we go, it's a little bit better. So again, usually you would use this method when the line is in standard form, like this one's in full standard form, or kind of like in half standard form, where they've already kind of started to balance the constant over onto the right side. Again, only needing 2 points to graph a line. So So if you calculate the x and y intercepts, then you connect those two, and then those would serve to make your line. Okay, well,